Welcome back to Algebra with Miss Swartz. Today we're going to look at your review that you did. Kind of lengthy, so we're going to get going right away. We'll get started on the first part of it here, and then we'll separate it into two parts here. So, number one, determine whether the relation is a function. So remember, it's a function if all of our inputs have exactly one output. Okay, so if I look at all my inputs, 9, 7, 5, 3, 1, they each have one output. So yes, this would be a function because each input has exactly one output. Same with 2. If I look at 5, 3, 1, 3, and negative 1, well, with this one, I have 3 and 3. So I'd have to say no on this one because they have two different outputs. If they have the same output, that would be one thing, but they have two different outputs there. So not each input does not have the exact same output. All right, I had a lot of questions on 3 through 5. So domain and range. Remember, domain is all your possible inputs. Range is all your possible outputs. So you will have a couple of these, so you got to kind of grasp this a little bit. So with the dots, pretty simple because you're just looking at your x and your y values. So with the dots, I can say, all right, my x value here is my input here is going to be at -1. So that's one of my points. I have a dot here at 0, at 1, and at 4. It doesn't matter the order that you put those in. Just list them out. The range now is all your y values, so your output. So your output's at 2, 0, -2, and -1. Those are all of our points. Okay, for number 4, if you notice, this graph goes on forever. So we're going to keep going on because of the arrows forever. So our domain, is there any number that with our arrow going that way that it could not reach? No, so these are going to be all real numbers there. With our range, though, the smallest number that we see lies right here at -2. So y just needs to be greater than or equal to -2, because then it goes on forever. It could go up as high as it wants. Okay, and then number 5, we have ending points. So for both of these, we're going to have two-piece inequality. This one we're going to be using x, this one we're going to be using y. So our smallest input, or our smallest x value, is at -2. So x needs to be greater than -2, greater than or equal to, because we have a closed circle. If there was an open circle there, it would just be greater than. But it needs to be less than or equal to our smallest number, which is at 2. Okay. Now our y's, we need to look at the y-axis. Okay, so our smallest number is at -2 as well, greater than or equal to because of the closed circle, but it needs to be less than or equal to, in this case, 3, because it goes up to 3. So if you have questions on that, let me know. We can talk about domain and range a little bit before the test. All right, and then we have to determine whether the table graph or equation represents a linear or nonlinear function. Okay, so remember the few different ways that we do this. First of all, on a graph, it needs to be a line. Well, is this just a line? Well, I guess it could form a line there, but we're missing that point. So this is an obvious no, nonlinear function, because these are just points. We don't have a line. We want a line when we're talking about linear. Then if we're looking at a table, okay, we need a constant rate of change. So as x goes up by 3, y has to have a constant rate of change. So as x goes up by 3, y increases by 2. So yes, this is linear because of the constant rate of change. And finally, we have our equation. So our equation needs to be in the form y equals mx plus b. We may have to manipulate to see if we can get it to there. But what we have is y equals x times x plus 3. So if we were to distribute this, what we'd actually have is x squared plus 3x. Well, does that look like y equals mx plus b? Nope. So this is non-linear. Okay, so again, those are all very conceptual things. Just kind of have to know how to do them. we come up into some math when we reach number 9, 10, and 11. So now it wants us to evaluate the function when x is -1, 0, and 4. So what we're going to be doing is we're going to be plugging in those numbers for these functions. So we're going to plug in -1 first. So we get 3 times 1, because -1 times -1 is 1. So we get 3 minus 1, or 2. Okay, so that's for -1. For 0, we would just plug in 0. 0 squared is just 0. 3 times 0 is 0. So -1 is our answer. And then for 4, plug in 4. And I've been doing this wrong the whole time. It should be plus. So this is 4. And this should be +1. I apologize. Alright, so we get 3 times 16 plus 1, which would give us 48 plus 1, or 49. So there's all our pieces. Okay, so we're going to do the same thing for 10. We're just plugging in our numbers here. I know you kind of run out of a little bit of space here, but... So this one is subtraction. So we get 2 minus 4, and -2 would be our answer. Then we plug in 0, so -2 times 0 minus 4, so 0 minus 4 is -4. And then finally 4, going through this pretty quick, but hopefully you can see if you did it correctly. We would get -12. Okay, and the last one, we're in absolute value, so make sure you do the operation first inside the absolute value. So we get the opposite of -1 is 1. So we'd have 6. So 6 would be your answer there. And we have the opposite of 0. Well, that's just 0. So 5 is our answer there. And then we have 4 plus 5. We get the absolute value of 9, which is 9. So here are all of your answers after I fixed these two. Okay? All right, so moving on. Try to get us going here. Now it says graph the linear function. We've talked about a couple ways to graph, and you're going to do more graphing on the next video. But we're going to just look at 12. If you have questions on 13 and 14, you can kind of refer to the next video that does more with graphing, so just to save us some time. So with this, we are in slope-intercept form. So my slope here, my m, remember, is 1, and my y-intercept is 7. So I'm going to hit the graph at 7. So you have to be really careful with this because it's going up by 2's. So 6 and 7 would be about right there. Okay? And then you're going to use your slope, disappeared on me, that goes 1 over 1 because my slope is 1. Okay, so I'm going to go down 1 to 6, and over 1 would be here. So again, I'm losing my down 1, over 1, so I have to go in halves. Oops. Okay, I did this wrong. I apologize. If I'm going to go down 1, because I'm out of room going up, I have to go to the left because it's a positive slope. So I go down 1 and then over 1. There. I can get my pen to work. Okay. Down 1, over 1. So my line would look something like this. So just be careful with the separations of the graph there. Really, you only need 2 points to graph a line. So like I said, we're going to skip these. If you have questions on them, come see me. You just need to know your slope and your y-intercept. That's going to help you out. Okay, so if we look at 15, it says find the value of x so that the function has the given value. So I'm going to plug in -5 for f of x. So now I'm going to solve for x. So I'm going to subtract 3, get negative 8 equals, got to keep that, negative x. So if I want x by itself, divide by 1, divide by negative 1 or multiply by negative 1, but x would equal 8. Okay, same thing here. We're just going to plug in 1/2 for t of x and work from there. Okay, so now we're working with a fraction, but we have 4 and 1/2 equals 2x. I'm actually going to change 4 and 1/2 to a mixed number, so I'm going to go, or to an improper fraction instead of a mixed number. I'm going to go 9/2. So to get x alone, I would have to divide by 2. Well, if I'm dividing by 2, I'm actually multiplying by 1/2 to make my life a little bit easier so I understand what's happening. Dividing by 2 is the same as multiplying by 1/2. So 9/4 would give me x. So that one was a little challenging. Okay. Pretty simple there. Then finding the x and y intercepts of each of these. So for x-intercept, y equals 0. For y-intercept, x equals 0. So you're just plugging that in. So if y equals 0, we have 2x equals 6. We divide by 2, and x would equal 3. If x equals 0, we have 3y equals 6. So y equals 2. So your order pairs would be 3, 0, and 0, 2. Same thing here. If y equals 0, we'd have negative 3x equals negative 30. Divide by negative 3, x would equal 10. And if x equals 0, we'd have 5y equals negative 30. Divide by 5, and y would equal negative 6. Okay, so then over here, if y equals 0, we'd have 1/2 x equals negative 8. To get rid of 1/2, we're going to multiply by the reciprocal of 2, so x would equal negative 16. And then if x is 0, we just have y equals negative 8. So those are your x and y intercepts. Okay, 18 and 19, we're just using y2 minus y1 over x2 minus x1. And I had some questions. How do I know which one to pick? Doesn't matter. Pick 2 points. This can be x1 and y1. This can be x2 and y2. You could pick this for x1 and y1 and then this one for x2 and y2. Just got to pick them. So if my y2 is 4 and my y1 is 7, I would have this. Then I have negative 3 minus negative 5. Be careful with your signs. So we get negative 3 over positive 2. That is our slope. So I'll use these two for this one. So I have 1 minus negative 7 for my y's, and then 2 minus 2. Well, I end up with 8 over 0. Can you divide by 0? Can you split things up into 0 groups? No, this is an undefined slope. If you know what that looks like, okay, on a graph, if it's undefined, this is going to be a vertical line at 2. X is going to equal 2 there. Okay, we haven't done a ton of story problems, but this is pretty simple. It gives the function here, c equals 100 plus 0.3 m represents the cost in dollars of renting a car after driving m miles. So it says, what would the cost be to rent the car and drive 100 miles? Okay, well, if you know the miles, you're going to plug in where you see miles. So c equals 100 sorry, it's hard to read there. 100 plus 0.3 times 100 because it's 100 miles. So I plugged it in for m. So now I'm just going to solve for c. So 100 plus 0.3 times 100, we're moving our decimal over 2 spots, so 30. So the cost would be $130. Okay, how many miles would a customer have to drive for the cost to be 149? So now we're looking with the cost, so we're going to plug the cost into 149.50, and that's going to equal 100 plus 0.3 m. So I'm just going to solve. Subtract 100. Pen would stop not working on me. Okay, so I get 4950 equals 0.3 m. To get m alone, we would divide by 0.3. So when we divide by 0.3, we get m is equal to 165 miles. Okay, we already pretty much did this, so just use y2 minus y1. Over x2 minus x1. I don't know what is going on. Okay, so if you have questions on those two, come see me. We'll talk about them. Okay, the last two, though, we haven't done a whole lot with, so I want to make sure I touch on those, and then we'll be done with the first part of your review. Okay, so with these, it says write an equation in slope-intercept form. So you need to write an equation in the form y equals mx plus b. Okay, so first you need to figure out your b. Well, your b is your y-intercept. Where does it hit the y-axis? It hits it at 4, so that's going to be our b. Then you need to figure out your slope because everything else is already there for you. So pick another point out and find out your slope. We go down 2 over 2. So negative 2 over 2, or another way to say that is just negative 1 or negative x. That would be in slope-intercept form. Okay, same thing with this one. We want y equals mx plus b as our slope-intercept form. Where does it hit the y-axis? It hits it at negative 2. And what is our slope? So you got to find 2 points that you can obviously see. Here's a point, and here's the point that you saw. So you're going down 1, 2, 3, 4, 5, 6, 7, and over 1. So your slope is negative 7 over 1, or negative 7. So there we go. And this would be your slope-intercept form. All right, we will continue on in the next video going over the graphing. Have a great day.